Hey students, welcome back. This is weak bases, and we are talking about this is the second part of 8.3. So we're going to do weak bases. They are very similar to weak acids. So we've got the base ionization constant, which we're talking about. This is just how much a base breaks apart. Ooh, let's try that again. All right, how much a base breaks apart. So like this is telling us, just like the Ka told us how strong an acid was, this tells us how strong a base is. So our reaction, this time we're going to use B to represent base, and we're going to add it to water. And you can see what happens here. Remember, according to the Bronsted-Lowry definition, that a base accepts an H plus, right? So it's going to accept an H plus from H2O, and we're going to get HB plus, and we're going to get an OH minus. So to write our equilibrium statement there, we're going to say K sub B is equal to HB with a plus and OH minus. All right, over our concentration of B. All right, B stands for base. All right, let's see if we can't put this into play. This is exactly like all our other equilibrium constants or equilibrium calculations. So let's see how we do there. So our first step is we've got NH3. It's going to be reacting with water, H2O. All right, we're going to get NH4 pluses and OH minuses. So we have an initial concentration of NH3 of 0.10. Remember, what do we don't care about? 0, 0, minus X plus X plus X. So over here we've got 0.100 minus X, we've got X, we've got X. Over here, kind of doing the full workout, we've got Kb is equal to the concentration of NH4 plus times the concentration of OH minus over our concentration of NH3. So now we're just ready to plug it in. So we've got 1.76 times 10 to the negative fifth is equal to X times X over 0.10 minus X. Remember that X is still going to be very small, so we can cross it out. So we have X squared is going to be equal to 1.76 times 10 to the negative sixth, right? That's where we're at. Now, if we take the square root of that, right? Square root, and we should get X, which is going to also be our hydroxide ion concentration, which is the first thing we're looking for. We're going to get 1.32 or 33, 1.33 times 10 to the negative third, and that's molar. All right, so that was our first step. Now we need to find the pH. So if we go over here a little bit, all right, we know pOH is equal to the negative log of our hydroxide ion concentration. So we can plug this in right there, right? And so if we just hit the log of that, negative log of that, our pOH is going to be equal to, and we're going to keep 3 past the decimal, so we're going to say 2.877, 2.877. That's our pOH. So to get our pH, we're going to take 14 minus that 2.877, and we should get 11.123. pH is going to be equal to 11.123. It's kind of a terrible 3. Let's try that again. All right. There we go. And there's our answer. So pretty straightforward, hopefully. Hopefully we're all good with that. And let's move on. All right, now let's try another one. This time we have methylamine. Now the reason I kind of included this one is because I don't really know the formula for methylamine. So what I'm going to do is I'm just going to put an MA, right? Methylamine, right? We're going to add that to water. We're going to H2O it. All right, now over here we're going to get NaH with a plus, right? I'm just going to take one of those H's from water and we're going to go with the OH minus there. All right, so we know our initial concentration is 0.33. H2O, still don't care about. 0, 0, minus X plus X plus X. and we've got 0.33 minus x, we have x, and we have x. So I'm going to kind of skip ahead here, right? So over here, we're going to have 4.4 times 10 to the negative fourth is equal to x squared over 0.33 minus x. All right, we can lose that minus x. So if we're going to take 4.4 times 10 to the negative fourth, all right, and we're going to multiply that by 0.33. All right, that gives us x squared is equal to 1.452 times 10 to the negative fourth. All right, if we take the square root of that, x is going to be, which is also our hydroxide ion concentration, which is the first thing we're looking for. We're going to go 1.20, how about let's say 1.2 times 10 to the negative second. All right, molar, so there's that. Okay, our next step is to plug that into our pH and POH. All right, so POH is equal to the negative log, right, of that number right there. So let's go ahead and plug that baby in. If we just hit the negative log of that, we're going to get POH of 1.92. And so a pH of 12.08, 12.08. And there we have that. Awesome. So we're good to go there. So now we need to take this just a little step further, and we're going to go percent ionization. Percent ionization can be used a lot of different ways. All right. Percent ionization can be used for acids. It can be used for bases, because a lot of times we want to know how much an acid breaks up or a base breaks up. So our key is looking at it that way. Percent ionization then tells us how much something breaks apart. Let's say a substance, and using big fancy words, dissociates. All right, what that means is breaking apart. All right, so to find that, we take the concentration of our ionized acid or base, or could just even be a formula, right? And then we take that over our initial concentration and then times 100. So let's see, we've got an example here. We've got HNO2, which is an acid. So we're going to write our little reaction, HNO2, double-sided arrow. We get H pluses plus NO2 minuses. All right, we got 2.5 there. 0, 0, minus x, plus x, plus x. 2.5 minus x. That's x, that's x. Jumping ahead here, so we've got 4.6 times 10 to the negative fourth is equal to x squared over 2.5 minus x. Lose that little x, right? So we're going to take 4.6 times 10 to the negative fourth, and then multiply that by 2.5, and we're going to get x squared is equal to that 0.00115. All right, square root of that. This is what we're looking for right here. We're looking for this number x because that's our H plus, right? And we're going to get 0.0339, 0.0339. All right, from there, now we're ready to plug it in our formula. Concentration of our ionized, 0.0339, and we're going to divide that by 2.5, and then multiply that by 100. So divide by 2.5, and then multiply that by 100, and we should get 1.36%. So that's not very much broken apart there. Okay, so HNO2, very weak acid. All right, see you on the next one.